This is Devinder Kaur and welcome to my YouTube channel, The Enlightened Room. In this video, we're going to talk about the Kepler's laws of planetary motion. Well, we will not just study about this planetary motion, these laws, but we will also study what made Kepler to make these laws and who was Kepler actually, what were his discoveries and many more things about him. Well, Kepler is known as the founder of the modern optics. Why? Well, he had made many firsts. Like he was the first to investigate the formation of images through or formation of pictures through pinhole camera. And then he was the first one who discovered about the, or you can say who also described about the real, inverted, virtual and upright images and their magnifications. And he was the first to investigate or to study about the vision by refraction, vision of our eye by the refraction of light. And not just these first, he had made many more first, and these first were in astronomy and in optics. That's why he is known as the founder of modern optics. Now let's talk about this Kepler's laws of planetary motion. Well, in 1601 there was a mathematician whose name was Tycho. Well, Tycho had made many precise theories, many precise calculations related to the orbits of the planet, and that planet was Mars. So when in 1601, after the death of Tycho, Kepler studied those theories, those discoveries or studies made by Tycho, and what he found that the orbit of Mars is elliptical. That means Mars revolves around the Sun in elliptical orbit, and this made him made these two laws. And then after the further investigations and further discoveries, he was able to make this third law. Okay, so this is how we come up to Kepler's laws of planetary motion in 1609. Now let's talk about Kepler's first law. In Kepler's first law, he says that every planet revolves around Sun in an elliptical orbit. Okay, here is the elliptical orbit and here is the Sun. Okay, so every planet revolves around Sun in an elliptical orbit with the Sun situated at any one of the foci of the ellipse. Okay, in the elliptical orbit of the planet, the line joining the center of the planet to the center of the Sun sweeps equal areas in equal intervals of time. Now we are going to study these two laws first. Now in the first law, they had the Sun situated at any one of the foci of the ellipses. In an ellipse, there are two axes. One is major axis and other is minor axis. Now let us say this AB is the major axis and this CD is the minor axis. And ellipse has two foci. That foci is the plural of focus. Okay, so this is focus F1 and this is focus F2. And the Sun would be situated at any of the focuses. Okay, so Sun, well, according to this, Sun is situated at focus F1. Okay. Now, in the elliptical orbit of the planet, the line joining the planet to the center of the Sun sweeps equal areas in equal intervals of time. Now, what does he say in this? Okay, I'm going to erase this now. We're going to only keep the Sun now. The planet revolves around Sun in this orbit, in this direction. Okay. Now, from this area, here is the Sun. From this, here is the area of the planet revolving around the Sun in elliptical orbit. We will call this area P1, P2. So the area would be O, P1, P2 or P1, O, P2. Okay. Now this area is much farther from Sun. Now let's come to this point. At this point, the planet is near the Sun, right? And here is the area P3, P4. Now according to this law, these two areas are equal. That means area P1O, P2 is equal to area P3O P4. Okay, so what does it mean? The sun sweeps equal areas in equal intervals of time. And well, you all know that from this point, what would happen? The speed of the planet would become quite slower. Okay, when we talk about it experimentally, the speed of the planet from here would become quite slower, and the speed of the planet here would become quite faster. That means this arc is smaller than this arc. Arc P1, P2, P2 is smaller than arc P3, P4. Right? Now what does it mean? It means the planet to the center of the sun would sweep equal areas in equal intervals of time. But the planet here would become slower in speed as compared to here, as here it would become quite faster, as it would be closer to the sun. Here it is far away from the sun. That means the planet does not revolve around the sun in constant speed or at constant speed. Okay. Now let's talk about the Kepler's third law. In Kepler's third law, what they say, the square of the time period of revolution of a planet around the sun. Now let us talk about the square of the time period. That means it would be mentioned as t squared would be directly proportional to the cube of the semi-major axis. Cube of the semi-major axis, let us say it is r of the elliptical orbit. Now r is, let us say we had AB here, right, which is the major axis of the ellipse, right? Now semi-major axis means AB divided by 2. Now this AB divided by 2 would be the path followed by the planet that to revolve around the sun. Okay, so this is the semi-major axis, and the cube of the semi-major axis or the is directly proportional to the time period, square of the time period of revolution of the planet around the sun. So this is what the Kepler's third law states. That means t square would be equal to some constant times r cube, and then you will get the various formulas here. Okay, so this is up for today's video. We had studied about a little bit about Kepler and its laws of planetary motion. We had briefly explained about the laws of planetary motion of Kepler, and stay tuned for more videos like this. Subscribe to my channel for more videos like this and hit the bell icon. Thank you so much.